Hi everyone, we are fan Linwu, Siyuan, and Zinian from NLP QA presenting to you our NLP question answering project. The overall system consists of two major parts, question generation and question answering. This diagram summarizes all the modules we have implemented. You're welcome to pause the video and take a look, otherwise all the details will be discussed later. Here are all the tools we have used in the project for various reasons. The overall flow of our Ask program goes like this. First, we segment a given article into sentences using NLTK sentence tokenizer. Then we apply coreference resolution to the sentences to replace pronouns with their referred names. After coref, we discard the very long sentences since those often contain long clauses and will generate awkward questions. Now we feed the question to Stanford call NLP parser and generate a parse tree. Then we look for the regular factual sentence pattern NPVP in the parse tree. The matched candidates go into binary and WH question generation modules. To transform a statement to a question, we first identify the head verb of the VP. For this example, where we have regular verbs, we transfer the tense of ate to do and insert did to the front. There are other cases where auxiliary verbs or modal verbs are the head verbs. In such cases, we simply move the head verbs to the front. We want to ask no and confounding yes questions as well. So based on the correct question, we can replace meaning of entities with their antonyms or synonyms or add negation to the question. And for WH type questions, our system could ask who, whom, what, when, where, how many, and why questions. For WH question like who, whom, what, when, and where, we could get the name entity tag of each word in a given sentence with the help of an ER tagger. For example, we could ask whom or who question type given a person tag, a when question given a date tag, and so on. After identifying what kind of WH questions could be asked given a constituent, we simply delete the target constituent and insert the question word to the head of the sentence. Auxiliary or modal words might be added to make the sentence grammatical. We were conservative when asking WH questions. We only ask questions if all of the constituent members are tagged by the same NER to avoid breaking the grammatical structure of the original sentence. After asking, we use our answering module to verify the generated questions. If the question is not answerable based on the retrieval score, it is a bad question and will be ranked lower. Finally, to ask more interesting and meaningful questions, we sample different types of questions with different weights to output. Before answering questions, we use Lucene to match question with answer sentences. We chose Lucene search because we found out vanilla TF-IDF didn't work well. Lucene will return a BM25 score with each retrieved sentence. If the best score is below a threshold, then the answer will be I don't know, since this is probably a bad question. Otherwise, the best answer will be used as reference to extract the answer. We parse the set question using Stanford parser to check the sentence type. For those wrongly parsed questions, we identify the question type by looking for the keywords. When answering binary questions, in order to better match to the reference sentence, we first transform the sentence to declarative form. For negative binary questions, we will delete not. For the transformed binary question sentence, we then extracted the keywords in the sentence, which include noun, verb, adjective, and adverb. We then compare if all the keywords are in the reference sentence. If yes, we'll answer yes. If there are keywords not present in the reference sentence, we then check the antonyms of the words. In this example, word quickly doesn't exist in the reference sentences, so we search for the antonyms of quickly and found slowly. Then we checked if the antonym slowly exists in the reference sentence, and if it does, we will answer no for these binary questions. Otherwise, we will answer yes by default. For the wrongly parsed binary question, we convert both question and reference sentence to backup words. Then we are able to check the synonyms and antonyms using the same logic as before. When answering WH questions, our system will parse the answer sentence and tag its name entities. The results will be fed into a module that selects the candidate answers. Then the system will recursively loop over subtrees and examine if each matches with the required NER tags of the corresponding WH word. If so, it will be selected as a candidate and added to the answer list. When there are multiple candidate answers, we will select the one from lower level subtree and overlaps the least with the question. Consider the same example after the NER and parse tree are generated. John is selected at the first, since it forms the NP itself and tagged as a person, which exactly fits the requirement of answering WH question. As the loop continues, green apple is selected as well, but this NP doesn't contain any person tags. Similarly, 8 green apple quickly is also discarded because it is a VP instead of NP. To evaluate the effectiveness of our answering strategy, we developed an automatic evaluation pipeline for the answering module using the data QA pairs. Since there can be more than one correct answer to a question, we defined 2 matrix hard match and soft match accuracies. Then we were able to use the pipeline to evaluate our design choices. We came up with these improvement ideas after manual evaluation of our answers. But we wanted to know whether a local fix improves the system in general. So the first experiment is the phrase NER tag matching criteria for WH answering. It turned out a loser criteria works better. The second trade-off experiment is for binary answering, whether we check if all synonyms else no, or check if any antonyms else yes. From the results, the latter performs better. So this concludes our project. Thank you for watching.